everybody, and hopefully that you not you don't feel sleepy after having lunch. Okay. So now today I want to tell you about the potential contribution of seaweed cultivation to eutrophication mitigation in concentrated marine farming areas in Vietnam. And, what I want to talk today. Yeah. You know that Vietnam aquaculture industry holds an important position in the global stage. Vietnam is the top 10 aquaculture producer globally. You can see it. Yeah. Oh. And ranks the third in aquatic animal export by value. Just after China, Norway, and a leading exporter of pangasius catfish. And recent statistics is over 5.4 million tons of farm aquatic product, and the export value about $10 billion. And here the key farm species with mariculture, nearly 800,000 ton product, and including Asian sea bass or barramundi, grouper, pompano, cobia, lobster, seaweed. And with brackish water aquaculture, nearly 1.5 million tons of products, including shrimp, black tiger shrimp, and white lead shrimp, and mollusk. And with freshwater aquaculture, nearly 3.1 million ton, and mainly pangasius catfish and tilapia, giant freshwater prawn. And here the key marine farming system with the fat aquaculture species. We have a traditional sea cage, mainly for marine finfish and spiny lobster, yeah, including the Panulirus ornatus and Panulirus homarus, yeah. And with the high density polyethylene sea cage, mainly for marine finfish, especially barramundi and cobia, and also the pond system for marine finfish too, but mainly for grouper and some for pompano. For the suspension and deposit feeder, we have the long line system for pearl for oyster, and floating raft for oyster, green mussel, and otter shells. And for bottom farming, we have the tapestry shell or otter shell in the cage like this, and later on the bottom, and sea cucumber. With the nutrient absorber species, we have three groups of seaweed. The first one we go Gracilaria group, and the second one is the eucumatoid seaweed, and the third one is sea grape seaweed. And we have the long line of floating raft, mainly for eucumatoid seaweed, and the pond system for sea grapes and Gracilaria, and for the tank system for sea grape. Here the regional highlights. You can see on the map from the south to the north. Southern Vietnam here is the Mekong Delta and two Ho Chi Minh City, and the central Vietnam from Long Dong province to Thanh Hóa province, and the rest the northern Vietnam. And along the coastline of the country, mainly we have marine finfish sea case, but in the central Vietnam, especially the southern central Vietnam, like Đắk Lắk, Khánh Hòa, Gia Lai, we also have some sea cave for lobster in this area, only in this area, northern central Vietnam. And for the offshore area, from the coastline, more than 3 nautical miles, we have offshore area, mainly for marine finfish. And now in the country, we have about 30 nearshore concentrated mariculture. You can see on the red dots. Yeah. And in the future, because now in the planning, we will develop 3 offshore concentrated mariculture area. The first one in Quảng Ninh in the north, and the 2 centers in central Vietnam, and 1 in the south in An Giang province. So and here the recent export species group. So we compare between 2019 and 2023. You can see that the marine fish culture production for export has increased recently from 18 in 2019, from 18% to 23% in 2023. So the number of concentrated mariculture area is also expected to increase. Therefore, the reducing eutrophication in concentrated mariculture area is necessary. We got here the next section methodology. The data we collected mainly from reports of Department of Fishery and the local governments, and literature review, and also stakeholder interviews like scientists, farmer, trader, yeah. And for carbon, nitrogen, phosphorus removal calculation, use the equation 1 and 2, and with the related information here. And for carbon sequestration formulas and assumption, we use the equation 3, 4, and this is the related information. And for the carbon pathway of cultivated seaweed, we adapted from Gao Auto 2022, and with some ratio here and corresponding citation. So for the carbon fixation, we calculate the sequestered. You include the sequestered carbon as shown in blue figure here, the refractory DOC, dissolved oxygen organic carbon, and buried in algal bed, buried in set, and exported to deep sea. And also we plot with the harvested POC, particularly organic carbon. And for the oxygen release, the amount of oxygen released by seaweed cultivation was calculated according to the photosynthesis equation, equation number 5. Yeah. So when every ton of carbon is fixed, 2.67 tons of oxygen are generated. So here the carbon that is involved include harvested carbon and sequestered carbon, as we mentioned previously. And for nitrogen and phosphorus released by fish or lobster mariculture, the released nitrogen and phosphorus by fish or lobster mariculture were calculated by the formula 6 and 7, and this is the regulated information, and with the assumption here, half of the fish increase in weight is from pelleted feed or artificial fish, and the other half is from traffic feed, based on recent investigation. And the content of nitrogen and phosphorus in pelleted fish 6.85% and 1.4% respectively, and for traffic feed they are 2.68% and 0.48% respectively. And the retention rate of feed nitrogen or phosphorus in fish is set at 30% based on previous study. And the production of marine farmed fish and lobster in 2023 is 46,000 tons and 3,800 tons respectively. Here, for the lobster, because we follow the Department of Fishery, but in practice, the figure should be bigger. The estimated FCR with the pelleted feed for marine fish is 1.54, with traffic feed for marine fish and lobster are 6.77 and 20 respectively. And for the required area to bioremediate fish mariculture, the area required to remove nitrogen (AN) and phosphorus (AP) released by fish lobster mariculture were calculated by the formula. We use the formula 8 and 9, and here the related information. So what we found, firstly, the potential for nitrogen and phosphorus removed for seaweed groups cultured in Vietnam. Here the Gracilaria, Eucumatoid, and sea grape group, and we have the nitrogen removal capacity with the Eucumatoid seaweed is the highest, while the phosphorus removal capacity is highest with the sea grape seaweed. And the second, we estimate of carbon fixation and oxygen production from seaweed group culture in Vietnam. And the carbon fixation capacity is highest with the Eucumatoid, but the oxygen release is highest with the Gracilaria group, because they have the production is high in Vietnam. And the third, estimation of nitrogen and phosphorus released by fish lobster mariculture in Vietnam. So the production of the fish and lobster in Vietnam here, 46,000 and 3,800 tons. And with some assumptions as mentioned previously, now we have the nitrogen released by using pelleted feed about nearly 1,700 tons a year. And nitrogen released by using traffic feed about 3,000 tons for fish, and for lobster nearly a half. And for phosphorus released by using pelleted feed, nearly 350 tons, and for released by using traffic feed 523 tons. So the estimation of the seaweed cultivation area to remove nitrogen phosphorus released by mariculture in Vietnam. So if we consider only one group of seaweed alone, we see here for the to remove nitrogen when we use eucumatoid seaweed, the area, the farming area for cultivation of seaweed, we need a smaller area compared with other group because they have a higher capacity to remove nitrogen. Similarly, for removing phosphorus, if we use the seaweed, we need a smaller area, farming area. And now we move to a case study in Vang Phong Bay. Did you know Vang Phong Bay is the bay in the north of this province? Yeah, it's about 100,000 hectare water surface. And here we have the marine finfish aquaculture production about 7,000 tons a year. And for lobster aquaculture production about 1,000 tons. And the total nitrogen relief by mariculture, including two groups, fish and lobster, we have the total nitrogen relief and total phosphorus relief here. So nearly 1,000 tons of nitrogen relief and 200 tons of phosphorus relief. But the seaweed aquaculture production is with the Gracillariae group, but about 180 tons of eucumatoid seaweed and 716 tons of sea grape seaweed. So the total nitrogen removal amount by seaweed about 15.4 tons. It's about approximately 1.4%. And the total phosphorus removed amount about 6.1%, 6.1 ton, so nearly 3%. Yeah. So we, if we consider only the seaweed, in reducing eutrophication from fish lobster mariculture, and assume that A, B, C are the area for growing Gracillariae, eucumatoid, and sea grape seaweed, respectively, to reduce eutrophication in this farming area. We have two scenarios. The scenario one, we combine three species to be combine three group of seaweed. But because the farming area potential for eucumatoid seaweed in Vietnam, especially in this area, the southern central Vietnam, it's estimated that about 10 to 15 times of the sea grape seaweed. So we use it like one equation. Yeah. So here we have the mentioned here for the nitrogen removal amount. We have 9A. 9 is the productivity of the Gracillariae seaweed in Vietnam, 9 tons per hectare per year. And eucumatoid, we have the productivity 15.2, and for sea grape seaweed 10 So we have the production for gracilaria in terms of removing nitrogen. We have 9A and multiply 1.41%. 1.41% is the nitrogen content of the gracilaria seaweed. So similarly for the phosphorus. And with the scenario 1, we have 3 species combined, and and to make it easy, we just use the positive integer. So we have the value for variable A, B, C as follow, and we got the result like that in output 3. Yeah. So it means that we can remove eutrophication from fish, lobster mariculture. And for the scenario 2, we apply like what happened at the moment, because now no gracilaria seaweed culture in the Vang Phong Bay, so we use zero. So only 2 species, 2 group of seaweed, Eucumatoid and cigarette seaweed, and we have the second scenario like this. If we see a bigger picture, so when we integrated seaweed farming into concentrated marine farming area as a component of IMTA, integrated multi-trophic aquaculture system. So we have the component species of IMTA system like this. The fat aquaculture species, we have fish and crustacean, and the fish in Vietnam, marine fin fish, like this. And when we use the blue, it is for the Vang Phong Bay. The other for the country in the country. Yeah. And for the organic extractive species, we have mollusk and echinoderms and polychaete. And for inorganic extractive species, we have seaweed. That's it. So when with the contribution from organic extractive species, we think that the area needed for seaweed cultivation can be reduced. So you can see here the estimated contribution of organic extractive species in nitrogen removal in the Vang Phong Bay. Yeah. So with the contribution here about the production nearly 1,600 tons a year, the organic extractive species can remove 5.24 tons of nitrogen from the seawater. So in conclusion, Vietnam's farmed seaweed have great potential to remove nitrogen, phosphorus, and produce large amount of oxygen. And Vietnam's farmed seaweed can play an important role as inorganic extractive species in integrated multi-trophic aquaculture system. And with some recommendation, the further studies on the farmed seaweed should be carried out, especially quantitative study of nitrogen and phosphorus absorption capacity of each species, and improve technical processes for seaweed aquaculture models, and integrate seaweed cultivation into concentrated marine farming planning, promote public-private partnership to expand the scale and value chain of seaweed, and apply ecosystem service payment mechanism for seaweed farmers to contribute to environmental improvement. So that's one. Thank you for your attention.